Hello guys, welcome to today's episode. And in this episode, we're going to be talking about networking fundamentals. Yeah, so stay locked in and let's get to this. Networking fundamentals. We have different types of them. We have the OSI model, the IP addressing, we have subnetting, we have switches, routers, that's often CCNA aligned, and definitely I'm going to make another video that's going to give a more detailed breakdown of everything in this video. So this is how data moves through the internet. The physical, that's from the brain when it's being inputted on the desktop or the laptop, then the data link to the network, then transport, session, presentation, and down to the application and all. So OSI model, which means Open Systems Interconnection Model. It's a conceptual framework that standardizes the functions of a telecommunication or computing system in 7 layers. Yeah, and the first layer, which as I said earlier, is the physical, and the purpose of the physical part is that why it's called physical is because there are things like the cables. Yeah, that's the physical cables being seen, the hubs, that's the ports at which it's being delivered to. Then we have the data link, that's the second, which is frame delivery and MAC addressing. An example, we have examples like Ethernet and PPP. Then the third one is network, and its purpose is for routing and for addressing. And the example, we have like IP addresses, like each and every one of our phones and Apple systems and our devices all have an IP address. And the transport is the purpose as from end-to-end communication, from one user to another user for a site, to an interface, and emails and all. An example is ITP and UDP. Then the fifth part is a session which manages sessions between apps, net buyers, and PPC. Then the presentation, that's the data format, the translation, and the encryption. Now, the example of SSL format, TTLS, and we have JPEG, that's JPEG, that's the picture format at which our pictures are being saved, and MP3 format, MP4, and the rest. In the application, that's the user interface, email, the browsers, and those. That's why you see when you want to search a page or any site you type, it always carries the HTTP before that. So I'm going to give the meaning of that in another video, the FTP and the SMTP. So this is how the OSI model looks like. This is how it's been organized and arranged. When I'm talking about IP addressing, as I said, every device, every phone, every laptop or personal computer has its own network, and it has a unique identifier which is called an IP, which is internal protocol. So IP address, internet protocol address. So we have IPv4, which is a 32-bit address. That's for devices that are 32 bits. Examples, this is it, this is how it comes. And IPv6, that's 128-bit addresses. This is the example, this is how it's been displayed if you want to check it on your device. So the types, we have public and we have private servers. So we have static versus dynamic, we have DHCP, then we have CDR notation, it's a combined MP. So this is the format at which it's been generated in 1 byte, 8 bits, 4 bytes, and this is how it's been generated. So we have subnetting. It breaks larger networks. It means breaking larger networks into smaller segments for efficiency and security. Minimizes network congestion, improves performances, manages IP ranges, and the key concepts. Subnet marks an example. This is how it comes 225, 225, 225, the number of hosts per subnet, and the binary match to calculate the range. So that's all about subnetting. So you'll see more about it in the video I'm going to make. So this is the IPv4 classes and the subnet marks. This is how the class A is being broken down. This is how the class B and the class C is. And we have switches versus routers. It helps you to understand the rules of essential networking hardware. The switch that connects devices within the same LAN, the same LAN network, then operates at OSI layer 2, uses MAC addresses to forward data. Then the router does what connects different network to network or a wireless network. So just like routers or personal Wi-Fi or pocket Wi-Fi or travel Wi-Fi's, that's it. And all of them, they operate under OSI layer 3, and they uses IP addresses for routing. So this is how the router and the switch to look like. Both of them, they offer similar services.